Okay, so I'm going to be doing the two physical changes first. So a physical change is a change that alters the state or appearance without altering the composition. So here I have a solid. It's just a piece of paper, has grit on it, and it's white. So if I rip it in half, the state remains the same, the composition remains the same, and the appearance only changes in that now there's two pieces instead of one. So since the composition did not change, it is qualified as just a physical change. And then right here I have the ice. The change already started to occur where it just started to melt. So as I like play with it in my hands, and then just as it starts to sit, it goes from being a solid to a liquid. So in this example, the state does change, but again, the composition remains the same in being that it's just still water. And now moving on to the chemical changes. So for the first one, I have just a match that I'm going to light. And again, so for physical changes, the compositions remain the same, and for something to be qualified as a chemical change, the composition would have to change. So as I light this match, the composition changes. There it goes. Okay, so first off, right off the bat, there's an odor that produces from lighting this. That is a sign that a chemical change is occurring, because there's an odor. And yeah, and it's also releasing like a gas, and you see light forming, which also is another sign of a chemical change. And yeah, so this is the first chemical change. Put it out. And then the second one is here. I have some baking soda, and then I have some vinegar. I'm not gonna pour too much in there because I don't want it to go crazy, but yeah, so this is going to be a chemical change where the compositions change, and these two substances are going to create a whole new substance. So the composition changes. So watch it occur. I kind of want to put them more. Okay. So yeah, that stinks. So that's the chemical change where the composition was altered. And